So guys, this is a spreadsheet that that generates, or what it does is it shows the um, displacement time graph, velocity time graph, and acceleration time graph. Like I said, I generated this so that it was supposed to be used by you guys during the test, but you're not going to be using Excel anymore. I'm going to be taking like screenshots from this and asking you questions that are going to be physics related, but it's going to be how you solve those problems using spreadsheets. So that's why I need to do this. So a couple of things that we need to sort out first is terminology. Okay, so in terms of spreadsheets, there are special words that we use to refer to certain things. Um, for instance, if I say cell address or cell reference, a cell address or a cell reference is going to be the location of particular data. On a spreadsheet,
So B3.
we have
Like
columns that are represented by the letters here. So the columns are A, B, C, D, etc. Okay, the rows are down the side here and go across. It goes 1, 2, 3, 4, so on and so forth. Okay, so when we do a cell reference or a cell address, if I say B3, okay, that's the cell reference. That's the where column B and row 3 intersect, and so that's B3. Okay, now I know some of you guys have done this already through IST or whatever. You guys know this, but for those people who don't know, that's what a cell reference is. Okay, that's a cell reference. Now, each cell, so each of these are cells. Okay, each of these little squares are cells, and they each have an address or a reference. As you can notice here on column A, I've put in some data for you already, and this I've said is time. So this represents the time in seconds, starting from 0, going up in increments of 0.5 seconds, all the way to 25 seconds. All right, so I put that in for you. These are numerical values. If I click on any of these addresses here, you can see that it's got a numerical value showing up at the top here. This is called the formula bar. Okay, the formula bar shows you what's in it. Excel takes different kinds of data, numerical data, text data, and formulas. Those are the three main types of data that you can put into Excel. Usually it recognizes anytime you put in a number, it says, okay, this is numerical data. I should be able to do calculations on this. If you have something other than numbers in there, if you have like letters or other symbols, it will recognize that as text. And basically, so here, this is text data here. It just says, well, I'm not going to be able to do calculations on that. These are just here to give us some information about other things. But the third type of data is the formula. Okay, so can I get everyone to please click on E3? Okay, can you guys all see that? Excel recognizes formulas when you type in an equal sign. As soon as you type in an equal sign, Excel goes, oh, you know what? I think he's going to be putting in a formula to do something. It's going to be a function to allow the Excel to do calculations or other things. So all formulas start with an equal sign. Sorry?
Wait, sir,
Yes.
should I be on Excel and not the Google Sheets?
Yeah.
Excel is probably going to be better at.
It automatically put me in.
Google Sheet won't show
Press the button that says download, bro. Just press the button that says download.
Yes, sir.
Okay.
Please keep going ahead.
All right. So it says here average, and then it's got the open bracket B3 colon D3 close bracket.
Oh yes, I do have that.
Yes?
Yeah, I do have that, sir.
All right. So when you see that, what that's saying is, so that B3 and then the colon D3, that's a range. A range of data is depicted on Excel by a cell address followed by a colon, then another cell address, and it says I'm going to be selecting everything between the first cell address and the last cell address. So B3 is here, D3 is here. So the range B3 to D3 are these three here, B3, C3, and D3. Understand that so far? Can everybody please click on generate data?
Oh. Yeah.
Don't have edits.
Oh, that's beauty, sir.
You can't edit, Lachlan, you can't edit? Did you say?
No.
That's the outliers, though.
Are you,
No.
did you open it on Excel or did you open it on Google Sheets?
Oh, I'll try again. I'll try again.
Oh yeah.
So what do you do to
It's
generate?
RNG, bro. RNG.
Can't be
Are these the
RNG.
macros that you were talking about?
Yes, this was my macro. Yeah. All right. So you should see that your data is going to be slightly different to mine. Okay. The numbers that you will have on your data is not going to necessarily match up with mine. The data now.
Bro, sir. I can
Yes.
hack your
I still
macro.
can't edit it.
You
So
still
I'm
can't-
trying to open
Did-
it in the sheets.
Did you try to open
I
it
can't
in
use the macro.
Excel? Did you guys open it in Excel?
Yes, I
Yes.
did.
Yes.
I'm
And
not
then
getting
when
that as an option.
when you opened it, did you allow it? Did you enable the macros? There should be something that pops up.
Oh
If-
yeah, I didn't enable that. Oh shit.
Yeah, you need to enable the macro to be able to.
Oh,
Because it
edit
says you'll
that,
get a
so-
virus.
No, you won't get a virus. I promise. All right.
Okay.
So, for those people who can generate the data, can you generate data, please? And you should see that it will generate a whole bunch of different. Basically, it will populate the columns here, and you should see that you will have a theoretical acceleration of 4.3 meters per second, or whatever it is that shows on yours. Yeah. Okay. So mine says 4.3. Yours will say something else. Okay. You should also see a whole stack of displacements here. Okay. So essentially the scenario here is someone has conducted an experiment where they had a ball that they rolled down an incline, and as it's rolling down the incline, it's changing its displacement. Yeah, that's what happens when you roll a ball down a slope. It changes displacement over time. All right, so what you should see here is that this person here performed the experiment 3 times. Okay, the first time he did the trial, after 0.5 seconds, he measured it to be 1.83 meters away. 1 second, 2.09, so on and so forth. He measured for 25 seconds. Okay, and it got up to like 1,343 meters away. He was a very patient person. Did this 3 times, and he came up with this data. He then used Excel to generate the averages here. So here is an average of these 3 tests that he did. So at 0.5 seconds, the average is 0.94. So how it did it was, using Excel, it said, I want to get the average of B4 to D4. Okay, I want to get an average of B4 to D4, and this is the average that it found. I got an average of B5 to D5 here, and this is what I have here, and so on and so forth. You can see that that's what they did, right? You can see that it says we're going to find the average of B7 to D7, so 8.66, 8.65, and 8.80. If we were to average that out, we should get 8.7. I want you guys to now go onto F4. Okay, now on F4, it says here that we're looking at instantaneous velocity. Now, instantaneous velocity, what's the formula for instantaneous velocity?
Displacement over time.
Isn't it final velocity minus initial velocity over time?
Very, very close there, David. It's actually V minus U divided by T. Okay, or change in velocity over change in time. Okay, so change in velocity, if we were going to have a look at this average here, so it says here that to work out what the instantaneous velocity is, it's E4, so E4 divided by A4. Is that the correct formula to use for instantaneous velocity? No, what's that giving us?
Wait, what's
It's giving us average velocity.
Average velocity.
Okay,
average velocity.
so this isn't actually the correct formula. for us to be able to get the correct formula, really what it's got to be is this displacement here minus this displacement here. So this is V, this is U, okay, divided by the change in time, which is going to be this minus this. Remember, we said there's going to be the change in displacement. So in this case here, I'm going to start off with an equal sign. What does the equal sign mean?
It makes it the
Function.
equation.
It's going to be a formula.
Something.
Okay, it's going to be a formula. Okay, so
That was close.
so if I do equals, this tells Excel I'm going to be putting a formula in. This is going to be my end displacement minus this here is going to be my beginning displacement. So that's, this here is V, this here is U. Yep. Divided by, and I'm going to do this in brackets, this minus this. That gives me this gives me the proper the proper formula. Now, I don't want to have to type that in for every single one of them.
So what are you going to do for that, son?
Okay, so what you need to do is you need to go over to the bottom right-hand corner of your cell that you've just
Understand.
you click on that. So, and then you drag it to the rest of your data. Now, notice that I've left the bottom one black here. So just leave that for the moment. Oh, hang on, I've just done something wrong here. Oh, my bad. So give me a second.
You put it in the wrong cell, I think. So
Yeah, it's supposed to be E. This is supposed to be E3.
Wait, what? The E5 minus E3.
Sorry, that's supposed to be E5 minus E3. That's my bad. So, okay.
So for F4, oh, okay.
Okay.
What did
It should, so you would have dragged that all the way down there. Now, the reason why I've left this blank is if I had a value here, if I copy that value across, it will look for, so this one here looks for this value minus this value. Okay.
Understanding.
Whereas this one here won't have a value down the bottom. So we're just going to leave that blank because anything that we put there is going to give us wrong data. That's why I left that blank.
So what changes have you made so far?
Okay, so I changed the...
Because it keeps going in and out. That's why the connection's really bad.
Okay, go to F4.
Yeah.
Yep, and I want you to see, can you see the,
okay.
the formula
A5
here?
minus 8. Yeah.
Yeah.
Fine. And then do you just drag that down the whole thing?
Yeah, so you have to go to the bottom right-hand corner until your icon turns, so your cursor turns into a plus, and then
so
you...
shouldn't it be,
black plus.
shouldn't it be E4 and A4?
Yeah, shouldn't it be E4, A4?
A4,
Like,
because
why
that's
is
in
it E5 minus E3 and not
Yeah,
E4?
why is it that? Yeah.
Because the reason behind that is...
Also, that's a starting.
Yeah, so this is at 0.5 seconds during that interval. Okay, it started from here, it ended at this point, at this point here during that interval. So remember, this whole time here, this occurs between 0 and 1. Okay, so to get the instantaneous here, what we really need to do is is the ones on either side of it. That's just how it works. Yeah, it is what it is. It is what it is.
That's what it is.
Well, how do you know that meme?
All right.
Thank
So,
you guys. Nice to see you. Sorry, Sir, just jumping in, saying hello.
oh,
Hope
hello.
everyone's doing all right. Yeah, good. Nice to see you. Kind of
Okay.
working on some cool physics there.
Yep. So we're looking at...
My next task is just to get on to updating that notification. So everyone got the email from me, okay?
Yes.
Yeah.
Yeah.
Excellent, cool. I'll get on to updating that this afternoon and give you a little bit more information, but we're looking for that happening Wednesday next week. And it's all going to be good. Anyway, I'll jump on out. It's lovely to say hi. And I'll leave you with it.
Thanks, sir. All righty. So, so you notice here,
Bill, right?
what we're seeing is
That
that the theoretical acceleration notice here that the theoretical acceleration is actually starting to match a little bit more what our experimental acceleration was. Is actually showing us that we're actually closer to what it's supposed to be. Now, if I was to then have a look at my experimental acceleration, once again, acceleration is also going to have to be the change in velocity over the change in time. So here, where it says that the experimental acceleration is F4 divided by A4, okay, so it's just going to go velocity divided by time. Is that the correct formula that we should be using? The formula for acceleration is the change in velocity divided by the change in time. And if I just put the instantaneous velocity divided by time, is that showing me any change?
You need to change instantaneous velocity minus
No.
initial.
So it's going to be good. It's going to be final.
Displacement.
So it's going to be final minus initial velocity over final minus initial time. So how would you write, if I had this here as the formula, what would be the new formula now if I want to do it properly?
F5
F5 minus F3.
Okay, F5 minus F3 over, yep,
A5
minus A3.
A3. All right, I put that in, okay, and then I'll drag that all the way down to there, okay, and that should be your experimental acceleration. So the acceleration is changing as it, as it goes from time to time, but that's fine. That's what we expect. If we have a look at your chart, and it'll be different again to what mine is. Have a look at your chart. Okay, what do you think this chart here is? This first chart here, what's this one?
Acceleration.
Position time graph.
What is it?
Displacement time.
Displacement time graph. Okay, so might be a good idea to change the title there to displacement time. You might just go displacement versus time. Excellent. All right. What's this one here?
Velocity time.
This is?
Time graph.
This would be
Acceleration.
Velocity
Is it?
time
Then what's the?
I think it's velocity.
Two of my graphs have just disappeared.
The acceleration.
Let's think about it for a second. Is it acceleration or is it velocity? This second one here.
Velocity.
Velocity. Okay. Okay.
Instantaneous velocity.
So this is going to
It's
be.
not constant. Oh.
Yeah. So this
No,
is
it's
going
not
to be.
constant.
This is going to be.
time.
Okay. This is going to be velocity versus time. And last but not least, what's this one?
Acceleration.
Acceleration.
Acceleration over time. Yeah. Okay. Now, this is to test how much you understand about graphs here. On these graphs, how can we, what's one way that we can check what the acceleration, the graphical acceleration, where would we find the graphical acceleration?
The gradient.
The gradient of what?
Acceleration time graph.
The velocity time.
The gradient of the
Velocity time graph.
velocity time graph. Let's have a look. What's the gradient according to this?
4.3.
4.3006, yeah? What's the theoretical acceleration?
4.3.
4.30. Okay, so
Wow.
that's working for us. What can we use the acceleration versus time graph to have a look at what the
Did not work for
theoretical-
me.
Instantaneous
No.
acceleration.
can we use this to look at what the theoretical acceleration might be?
I don't know.
No.
What do you want to look at, sir? Sorry.
Can
Yeah,
we determine the
It's
theoretical
plus at the
acceleration?
end.
Yeah.
What is it?
It's 4.3, you said.
4.3, but where is it? Where's that information on this acceleration
It's
versus
the
time?
line. The dotted
It's
line.
the
It's
It's
the
No.
y-intercept.
The y-intercept
of the
trend
line.
line.
It's the
Trend line.
y-intercept
Let's
of the trend
go.
line.
What do you
It's the
mean? Let's
y-intercept.
go.
This is the y-intercept, okay, 4.3139. If we were to draw a line there, it would intersect at that point, okay? This is our theoretical, sorry, this is our graphical acceleration according to the acceleration versus time graph. So if I was to compare my my theoretical acceleration with my graphical acceleration, I suppose, or my experimental acceleration, I can work out an error between them. Yeah. How do you work out the error?
Experimental minus theoretical over theoretical.
Yes, exactly.
Are you telling us this because it will be in the exam? I mean, in the test.
Yeah, it's going to be quite possibly going to be on the test. Yeah, because the way that we've done it is, you know, I'm going to be showing you guys screenshots. I'm probably going to be showing you guys screenshots of something similar to this. The data is not going to be the same, but I might ask you to work out like what some of the, you know, what some of the analysis is of the data that you're getting here. Yes.
How do you copy down all of the information from the first one from like F?
Okay.
F4?
So for, yep, that's fine. If you click on that cell, and then what you do is you hover over the bottom right-hand corner.
Yeah.
You should see that your cursor turns into a plus sign.
Yeah.
Yep. If you then click on that and then drag it down, that will copy it down to however far you want.
Okay.
Did you try that? Have a go.
Oh yeah.
Yep.
Yeah.
You know how we like had to make those equations to find the like acceleration and velocity?
Yep.
Will we have to like be able to write those equations into the cells in the exam?
You don't have to write any equations because we're not actually doing it on Excel. So what I might do is I might actually give you guys like an option between different ones. So we might make it multiple choice, say, to give you, you know, this to say this is the equation that we should have, and you have, you know, you just have to select the correct one. But you don't actually have. You just need to recognize what the equations look like, okay? But you don't actually have to write. You don't have to write it.
All right.
Okay.
Thanks.
So, gents, did anyone have any problems with the questions that I gave you guys for homework? Do you want me to go over any of those while I'm here? Yes,
what's homework?
Yes,
What's the
Narain.
homework?
7.
Oh yeah.
Question 7. Okay,
7?
let's.
Or...
So a quick thing,
Yes.
if we want to practice this, can we just generate new data and then do it once? And then is it okay if we send it to you to see if we've done it right?
Absolutely. Yeah. Yes, please.
Beauty.
Okay, so if the R² value for both the displacement and velocity functions were 1, shouldn't the velocity function be just the derivative of the displacement?
So all the R² value doesn't necessarily tell you how accurate the graph is. All it's showing you is how reliable it is. Okay, so it's just saying that if we keep doing this, we're going to get similar results. So that's a measure of reliability. It's not the measure of how close you are to theoretical. It's just a measure of how reliable your testing is. Okay, so if you get an R² value of 1, that tells you that, you know, if you were to perform, you know, if you were to do the same thing, you know, using another data point, you know, you can extrapolate or interpolate or whatever, then you have, if you have an R² of 1, then you have 100% confidence that your data point is going to fit along that trend line. That's all that's saying. Yeah.